How do these oscillating electrons contribute to the understanding of a material's internal structure, and why are they important for the overall analysis when studying a sample with an SEM? Could the interaction of these various forms of electrons provide complementary data, allowing scientists to create a more complete image of the sample's surface and internal properties? What implications do all these forms of electron interactions have for improving the resolution, sensitivity, and accuracy of scanning electron microscopy, and how can these signals be used together to give detailed, multifaceted insights into the sample's composition, structure, and characteristics? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the SEM scanning electron microscope operate, and what is the role of the electron beam in the process? Could it be that the SEM works by emitting an electron beam from an uppermost electron gun, which is the initial source of electrons? How does the focusing of the electron beam occur, and why is the gate used to focus the beam before it proceeds further? Does this focusing step ensure that the beam will be directed precisely at the sample surface? How does the accelerating voltage influence the electron beam's path, and what does it do to the energy and speed of the electrons as they pass through the electron optical system? Could the voltage cause the electrons to accelerate, thereby allowing them to carry enough energy to interact with the sample surface? What is the electron optical system, and how does it function in the SEM? Could the system consist of electromagnetic lenses that manipulate the path of the electron beam to converge it into a fine, focused beam? How does the fine electron beam, once focused, interact with the sample, and why is it important that the beam is finely concentrated on the sample's surface? Does this focusing help provide a high level of detail and resolution in the resulting image? What role does the scanning coil play in the process, and how does it help to scan the electron beam across the sample? Could the scanning coil be installed on the final lens, and is its function to move the beam across the surface systematically in a controlled manner? What types of signals are generated when the electron beam interacts with the sample, and how do these signals contribute to the overall analysis? Could they include secondary electrons, backscattered electrons, absorbed electrons, and characteristic X-rays, and why is each type of signal important for imaging and material analysis? How are these signals received and processed, and what is the role of the receivers? Could it be that the corresponding receivers capture the various signals produced by the interaction between the electron beam and the sample, sending them for further amplification?